In this video, I am going to solve the Fourier cosine transform problem. The problem statement is find Fourier cosine transform of e power minus a square x square, and hence evaluate Fourier sine transform Fourier sine transform of x into e power minus a square x square. Second one is prove that e power minus x square by 2 is self reciprocal under Fourier cosine transform. This is the problem statement. Solution is Fourier cosine of any function f of x is, this one is Fourier cosine transform f of s, not sine one, this one is a cosine transform of f of x is equal to 0 to infinity f of x cos px dx. Here the given function is f of x is equal to e power minus a square x square. Substitute in that equation, that is equal to 0 to infinity f of x is replaced with e power minus a square x square cos px dx. Euler's identity is e power j px is equal to cos px plus j sin px. In this integration, some cos px is there. Here cos px is the a real part of e power j px. Cos px is the real part of e power j px. Substitute here 0 to infinity e power minus a square x square cos px is replaced with real part of e power j px dx. Here rp of real part of 0 to infinity e power minus a square x square into e power j px dx. That is equal to the real part of 0 to infinity e power minus a square x square plus j px into dx. That is the real part of 0 to infinity e power minus sign a square x square minus j px into dx. Here a square x square minus jpx is replaced with some manipulations. Here a minus b whole square is equal to a square minus 2ab plus b square. Here a is equal to ax. A is equal to ax. Therefore, now this is transformed into ax whole square minus 2 term is not there. 2 here numerator and the denominator is multiplied with 2. This one is 2. Here a term is not also there. X term is there. X. Here x is there. Next a term is not there. Numerator and denominator is replaced with a because the xa or ax is the a. Ax is a. Okay, now the remaining x term is there. The remaining is gp. The b term is here. The b term is here. The b term is this is the b term. B. B square. Next b square. B square term is not there. Add and subtract b term plus jp by 2a whole square plus jp by 2a whole square minus jp by 2a whole square. From this one, a is equal to ax, b is equal to jp by 2a. The entire one is replaced with ax minus jp by 2a whole square minus the remaining term is jp by 2a whole square. Substitute here in this expression the real part of 0 to infinity e power minus. This one entire one is replaced with this expression ax minus jp by 2a whole square minus jp by into dx. Here the real part of 0 to infinity e power minus ax minus jp by 2a whole square. Here minus into minus plus e power jp by 2a whole square into dx. That is the real part of 0 to infinity e power ax minus jp by 2a whole square. Here j square is the minus 1, p square by 4a square e power minus p square by 4a square dx. that is equal to real part of 0 to infinity e power minus ax minus jp by 2a whole square. This is the constant term. Bring out e power minus p square by 4a square. Let ax minus jp by 2a is equal to t. Here a dx is equal to, this is the constant 0, dt. Dx is equal to 1 by a dt. Lower limit is in the x place a into 0, 0. Lower limit is 0. A into infinity, infinity. Upper limit is infinity. T values. That is equal to real part of e power minus p square by 4a square. T limits are 0 to infinity. E power ax minus jp by 2a is t, therefore minus p square. Here dx is replaced with 1 by a dt. That is equal to real part of, this one is 1 by a constant, bring out 1 by a e power minus p square by 4a square integral 0 to infinity e power minus p square dt. Integral minus infinity to plus infinity e power minus t square dt is equal to root pi. But here 0 to infinity is there. This 0 to infinity interval is converted into minus infinity to plus infinity. That is the reason here numerator and denominator is multiplied with 2. Therefore, a real part of 1 by a e power minus p square by 4a square into 1 by 2. 2 integral 0 to infinity e power minus t square dt is replaced with minus infinity to plus infinity e power minus t square dt. That is the real part of 1 by 2a e power minus p square by 4a square. This minus integral minus infinity to plus infinity e power minus t square dt is the root pi. Here all are real terms. Therefore, the answer is 1 by 2a root pi by 2a e power minus p square by 4a square. This is the Fourier cosine transform of Fourier cosine transform of e power minus a square x square is equal to root pi by 2a e power minus p square by 4a square. In the problem statement, first one, by using this answer, find out Fourier sine transform of x into e power minus a square x square. One important formula here is Fourier sine transform of x multiplied with x e power minus a square x. This is the actual function f of x multiplied with x. In that case, we use differentiation property di by dp fc of p. This one fc of p. Already fc of p is find out here. Minus sign means for cosine differentiation is minus minus sign. That is the reason here we use minus sign. Minus d by dp. Here we use root pi by 2a e power minus b square by 4a square. This is the formula. That is equal to minus root pi by 2a d by dp of e power minus b square by 4a square. That is equal to minus root pi by 2a e power minus b square by 4a square d by dp of minus b square by 4a square. Root pi by 2a e power minus p square by 4a square d by dp of minus p square by 4a square is minus 2p by 4a square. Here minus plus 2 cancel. Therefore, finally, root pi by 4a cube, root pi by 4a cube. Here p term is there, p into e power minus p square by 4a square. This is the Fourier sine transform of x into e power minus a square x square. In the second bit, Fourier transform of e power minus x square by 2. This one, e power minus x square by 2. E power minus x square by 2. Fourier in that one, Fourier proves that e power x square by 2 is the self reciprocal under Fourier cosine transformation. Fourier cosine transformation. We know that Fourier cosine transformation of e power minus a square x square is already derived root pi by 2a e power minus p square by 4a. Here, let a is equal to 1. A is equal to 1. FC of e power minus 1 square is 1, e power minus x square root by 2 into 1 e power minus p square by 4. This is the Fourier cosine transform of e power minus x square. Root pi by 2 into e power minus p square by 4. But find out in the second bit, find out e power FC of e power minus x square by 2. Now we're using scaling property, Fourier transform scaling property. Fourier transform scaling property is Fourier transform of f of ax is equal to 1 by a f of p by a. Here f of x is equal to e power minus x square. E power minus x square. Given function is Fourier transform of e power minus x square by 2. Here e power minus x by root 2 whole square. X by root 2 whole square. Here Fourier transform, here Fourier transform of f of x, cosine transform of f of x is equal to root pi by 2 e power minus p square by 4. Compare this one, f of ax here, f of small f, a, here a is 1 by root 2. Here a is 1 by root 2. The formula here is 1 by a, f of p by a. 1 by a, f of p by a, 1 by root 2, f of p by root 2 means p by 1 by root 2. That is equal to root 2 into Fourier transform of root 2 p. We know that f of p is equal to root pi by 2 into e power minus p square by 4. Root pi by 2 into e power minus p square by 4. F of root 2p is equal to pi by 2, root pi by 2 into e power p square and root 2p whole square. Is equal to root pi by 2 into e power minus p square by 2. Therefore, Fourier cosine transform of e power x square by e power minus x square by 2 is a constant is root pi by 2 is a constant time e power minus p square by 2. Also, e power minus x square by 2 and e power minus p square by 2 are the same. Hence, it follows. That e power minus x square by 2 is self reciprocal under Fourier cosine transformation. Under Fourier cosine transformation. Here, important point here is scaling property. Scaling property is f of Fourier transform of f of ax is equal to 1 by a f of p by a. F of 1 by a into f of p by a. Here f of x is equal to power minus x square by 2. Here f of ax e power minus x by root 2 whole square. That is the reason a is equal to 1 by root 2. A is equal to 1 by root 2. With this, the problem is completed. The scaling properties play an important role.